Welcome to the first module. This is part 1 of 3 different modules on functions. The standard C++ library provides a collection of pre-made functions that you've already encountered. In this module, we're going to introduce the basics of creating a user-defined function by demonstrating how dividing a large program into smaller blocks of code not only makes it easier to program, but more manageable, simpler to navigate, and allows code reusability. In this module, you're going to be learning how to call a function and create a function definition for your user-defined function.
For starters, it's important to know that in each program you've ever created, you've done at least one function, and it's the main. Here on the left, you can see that the main ranging from its header file on line 4 down to the closing brace on line 23. But this is a long complex function and not practical. What we're going to do to simplify it is divide the large problem at hand into smaller problems, each one tackling a specific task. This approach is called divide and conquer. On the right, we're going to quickly notice that at the bottom we have the main. That's because the compiler must have certain knowledge of these functions before actually using them. Later, we will go into detail on this and see another alternative in structuring the program. You'll also notice 3 more functions which resemble the main right above it. These will each hold their own specific task and can be called at any moment and as many times as needed. This will help simplify a complex program and allows for code reusability. There are 2 parts of a function. We're going to start with the part we've worked on many times before, the function definition. Now, a function definition is the code that composes a function. For example, the main that we see here. With it, let's discuss the parts of a function definition. The very first line is called the function header. It declares the function's return type, name, and parameter list, and doesn't end with a semicolon because its body follows. The return type we're accustomed to seeing is the integer, but functions can also be void, double, char, etc. The return type will be the value of the data type that the function is returning to the function that called it. Next is the function name. We always want this to reflect the purpose of the function. In this case, it indicates that this is the main. In general, the rules that apply to variable names apply to function names also. Following directly after the name, we'll always have a set of parentheses, known as the parameter list, where we declare variables and pass a value into the function, but for the purpose of this module, they will always be empty. After the function header, we have the body. The body of a function contains a set of statements that perform the function's operations and are enclosed in braces.
Every function definition has a function call except for the main, because the main is the starting point for every program. On line 14, we can see a function call. It's composed of a function name that has to match the function definition it's invoking, and it's followed by a set of parentheses called the parameter list and finalized with a semicolon. If we did a playthrough of the program, we have the function definition before the main so that the compiler can know the return type, parameter list, and type of every function before actually reaching the main so we can begin. Once there, the first line of code to actually execute would be in line 14, the function call named displayMessage. This will invoke its function definition, and we would move back up to line 6 where it would execute line 8 and print hello world. And since it's a void message, it's over once it reaches the closing brace on line 9 and then goes back to the following line of where it was previously in the main on line 15 to return 0 and end the program. Now, I want you to notice that the function displayMessage that was called is a void function. Functions have the capability of returning data to its caller, such as the main returns a 0 to the compiler. In the case of a void message, they will only compile the code it contains. In this case, it displays a message. And then it terminates and goes back empty-handed to its caller to continue where it left off. Let's look at the differences between the function call and function header real quick. The function call finishes with a semicolon because it terminates. The function header doesn't because the body follows. The function call holds any variable that are to be passed to the function, and the function header displays the variable name and type. The function header also contains the return type, and last but not least, their names must match.
Functions can be called multiple times and from anywhere in the program. In this example, I'd like to demonstrate how they can also be used in control structures such as a for loop. The program starts and the compiler will obtain the information of the function header for display message and continue in line 11 with the main. First, the program will print "we're inside the main." Then on line 15, it encounters a for loop where I equals 0, I is less than 3, and I++. Inside the loop, there's a function call named displayMessage. It calls it once, and we go up following the arrow to line 6 to the function definition for displayMessage. And all it does is print hello from inside displayMessage. Once it's done, we go back to where we left off inside the for loop, and now the loop ends and I equals 1. So we have to repeat that process again of calling the function displayMessage and printing out hello from inside displayMessage 2 more times before leaving the loop. After it exits the loop, it'll proceed to print out we've exited the loop, and it terminates. On the right-hand side, we have the program output, and we can see how it repeated the displayMessage function 3 times. Now, it's important to remember that when you call a function and it ends, it's like it's destroyed. Any variables and operations that were initialized and worked on will all be erased, and when you call it again, it will start from the beginning, and it's as if it was called for the first time. But we'll worry about that in the next module. In this program, we're going to complicate things a little and learn how to use multiple functions and how to call a function from inside a function. Let's first look at what we have. Aside from the main, there's 3 function definitions named first, second, and third. And on the right-hand side, we have the main with the program output underneath it. We're going to go step by step till we've completed it, and you can use the program output as reference to keep track of how it's played out. Let's start on the right with the main. The program will print out "we're inside the main." Then it reaches the first function call. Following the arrow, we reach the function first and print out hello from inside first. Up next is function call third. Notice that this function call is exactly the same as the ones we've previously encountered, except that this one is being called from a different function definition that isn't the main. We enter function third, and all it does is print out hello from inside third. We go back to where it was called inside the function first and continue to the following line of code and print out back inside first. This finishes the function first, and we go back to the main. Now there, the program prints, now we're back inside the main. Next step, we're going to executing function call second. It's the same steps as function first, so let's run through it real quick. We enter its function definition on line 16 and print hello from inside second. Then we enter function third on line 4 and print hello from inside third. Function third terminates, we return to function second to print back inside second. Then the function second terminates and we go back to the main and print now we're back inside main, and it's all over. What I'd like to take notice here is the order of the function definitions. Generally speaking, it's always good to keep them in order in which they will be easy for the programmer to find. In this case, we can see that function first and second are consecutive, just like in the main. But because this module we're using function definitions before the main, we have to remember that the compiler needs a function return type, parameter list, and type before encountering a function call. So for this reason, I've placed the function definition for third first, so it can have the information by the time it reaches its function call that is inside function first and second. Note that it's possible to have function calls and definitions that can be used multiple times, and some it's also possible to have some that are never used at all. We'll see that in the following. Alright, if possible, let's try to do this exercise as a practice. I'll give out the instructions and you guys can pause the video and give it a chance. Once you're done, just continue to the next slide where I will go step by step to completing it. First, let's read the instructions. Write a program that receives an IQ number, displays an IQ chart, and then tells the user his classification according to the chart and the IQ entered. This program must contain a function call for each classification and a function call to the IQ chart that follows. Now, first things first. Before starting a program, always know exactly what you're doing. Having to add a series of functions later could completely change the structure of the program, and we don't want to have to start over because of a misunderstanding. So let's see what we need. We need to first receive an IQ from the user, then a function for displaying the IQ chart given, and a function call for each classification. Looking at the chart, we have three classifications: above average, average, and below average. That's three more functions, one for each. Note that when creating a program, it's always a good idea to just grab a paper and pen and do a quick flowchart of events before actually tackling the program. The amount of errors that you could encounter will minimize, and you'll enter with a much better understanding of how to complete it. Alright, pause here, and when you're ready, continue to the next slide. Okay, time to complete the program. First, we'll start out with the main. This is every programmer's starting point. I'm going to give a small introduction and go straight to the first thing we need, receiving an IQ from the user. Now that we have that, the next step that I'm going to take to better display the program is I'm going to expand my main. As you can see here, the main is now at the bottom and I left some space for my functions. Now that we've got the IQ, let's give the user a quick peek at what the different classifications are by making the function display chart. Here you can see how I added the function call down in the main and the function definition above. Up next, we're going to use a control structure to decide which classification is the user. In this case, the if-else conditional statement would do just fine. I'm going to print out with an IQ of and quickly follow it with the IQ on line 31 so we don't have to repeat it for each case. So we got to be careful when creating a program. We can't just complete the program in one go, because if you make one mistake in a function, it could be repeated in each function, or simply affect the following function later on. And to not have a giant list of errors, try debugging after completing each function. Let's continue. Here I chose that if the IQ is 110 or higher, it'll display a message saying you are above average. Next, we'll do an else if that says that whether it's 90 or between 90 and 110, then the message it'll print out this time is your average. Know that these messages that the functions are printing out will be placed next to the message that was printed earlier in the main that says with an IQ of, and then it has the IQ entered directly after it. Last but not least, let's add the final function call and function definition, which is below average. For this one, I did an else, because if it wasn't the previous, then it'll be this one. And as we can see in line 22, all it does is print out you are below average. And then that concludes the program. Let's go through it. First, it displays, welcome, tell us your IQ, and I'll give you a classification. Then in the next line, it says, enter your IQ. And as a user, I'm going to pick 107 for my IQ. Now the program prints with an IQ of 107, and then we start with the conditional statement to see which function call will be chosen. First, is the IQ over 110? No, it's not. So I'll skip that one and we'll go to the second case, which checks if my IQ is 90 or between 90 and 110. Yes, it is. So it'll invoke the function call average and jump to line 16 and then print you are average. It'll go back to the main, skip the final case, and finish. And the final line of the output should say, with an IQ of 107, you are average. See, with this program here, we saw how not every function was called and how we can divide a much larger program into smaller segments, making it simpler, especially if we were to later on add on to it. Well, thank you very much. This concludes the first of 3 modules on functions.